Well, it looks like it's already 20 minutes. Good afternoon, everyone. My name is Andrey Zubkov. I'm the administrator at Pharma Technologies Group, DBA I'm in. In my presentation, I'm going to tell you about my module for Postgres, PG Profile. It analyzes the historic load. Well, this task actually we need it if something bad happens in the past in your DBs, and you need to know what that was. You need to find out what the reasons and look at the metrics, what ate how much. In fact, the task here is quite simple. Of course, we all have monitoring tools. In this case, this is a diagram of one metric, free space at the disk. Here we could take any other metric, but this is just a simple and understandable one. Everything's clear. So we have a development base, we have it has the volume, and then suddenly there is no free space, then we'll again have it, then we don't, but we were almost at the bottom. And in fact, once the developers actually broke down through the bottom and PG Profile didn't save me because the DB was down, but well, we were too slow to respond. But the next day, in fact, they gave me a very happy case. They did exactly the same, but it didn't end up in a bad way. Who actually used automatic Oracle OVR? Who lacks it in Postgres? Welcome on board. The module we developed had a task to add the functionality of Oracle to OVR to our Oracle. In Postgres, we collect less statistics, we have less possibilities to do that, but we can do the main things. So let's go and see what happened. The main question is what that was. We have a sudden change in the metrics when the admin was sleeping or was unavailable, and well, the reason may be any, but he cannot understand what happened in the past. However, monitoring is important because we need to know the time. What do we have for that purpose? Here I give two tools. POA, well, in fact, this is quite an old tool, and we also have PGBager. POA uses PGStat statements. It's written on Python. It has a very beautiful web interface. You can click there and see how much resources was taken by which part. But I think there we still get not enough statistics. PGBager, it analyzes the logs of the server. These two beautiful tools are mentioned here because they actually represent two big classes of tools. The ones who looks at statistics, like PGStat statements, and those that are analyzing logs. The approaches are different, as Mr. Kramer, in fact, yesterday was telling us about the analysis of journals. Well, it is great when you have an opportunity to write all your queries to journals and then do something to them. The performance of your system allows you to do that, and you don't have any worries about that. The second option is less detailed, which is PGStat statements. This is big arms, big armor, and but as a starting point for the investigation of the incident, it's quite enough. What is the mechanism we are going to use? It is actually the same as that of Oracle. What does it do? Every hour, Oracle makes snapshots of statistics that it accumulated over 1 hour. Of course, we need meters to do that. PGStat activity popular among all of us. It doesn't help here, unfortunately, because it shows us events which is happening at the time of the query, and well, the significant information, you may get it only in case this statement is happening right now. In all the other cases, to analyze historic load, it is of no use. So we need meters, PGStat database. This is a great gun that logs statistics on your database, on your cluster, and they are incremental, cumulative. From the moment of it started receiving statistics, it counts it. So we need to categorize the statistics, cluster it, and store them, the pieces of statistics of the past. I do not store big parts of statistics, I store increments. I will tell you later on why I need that. In first versions, I was taking absolute values, but it seemed to be not the right thing to do, so I switched to increments. For example, we have statistics, blocks read. At 10 there were 20, at 11 there were 40, of course, those are spontaneous figures, and at snapshot we will have, say, plus 20. In between snapshots we get 20 more blocks, we read 20 more blocks, so the statistics is accumulated as follows, as this. Observed views. These are the views PGProfile observes, and this is how it just collects the data into snapshots. User stat tables, user stat indexes. These are statistic views that count statistics on using object schemes, tables, indices, number of entries, inserts, deletes, dead entries, vacuums, and so on. Stat.io, a very useful statement that shows us which tables are referred to most often and to which indices. Stat user function. Well, again, here you can look at the frequency of specific user functions being run. PGStat database. This gives us statistics on the DBs of cluster. Snapshot. Well, this big head of the slider, this is what you need to do in this extension to get statistics on the cluster, to get a snapshot of the cluster. What happens when we're taking a snapshot? ng-profile in its intestine, inside, in the guts, it has statistics on the previous snapshot. It takes statistics from PGStat database and statistics on the objects of user schemes from all the DBs. There, in all the objects of user schemes, all the values of the last snapshot are stored. When we are taking the next snapshots, we can calculate increments using this data. In the block of snapshot tables, well, it is not for nothing that we put tapped and delta tables. There we store only top-level objects. The most frequent queries, the queries that took a lot of time, quickly growing tables, and so on. So they store only top-level data. For all the other tables, we do not store data for those, and the data on all the other tables, they are stored in last snapshot absolute values. DB-link, it is not the greatest thing, but we cannot do without it, because in one of the database there can be extension and it needs to collect the statistics of using user objects from all the database. It cannot do that from its own DBs, it has to use DB link. So it goes through DB link, it takes to the DB next to it, calculates all the deltas and saves those. PGStat statements. Well, we have a separate talk with that one every time after it takes a snapshot. Top of queries makes the snapshot, and then PGStat statements is cleared by PGStat statements reset. I haven't yet succeeded to avoid it because we do not know the algorithm of being squeezed out of state statements, and we do not know why some things are being squeezed out of that one. PGStat statement max cannot follow everything, and what if your cluster performs or processes more queries and some do not make it into the stat. But after resetting the DB and when we're taking the next snapshot, we think that there was 0 at this point last time. We cannot say whether it was 0 for sure, but at least we inform the user that it is 0 here, and it may be the case that you are losing something. If more than 90% of PGStat statement max was captured between snapshots that made it into the report, it means that the notification will be on top. But if in the whole repository there were snapshots that have more than 90% of PGStat statement max, they will be at the bottom of the report, and you can look at the overall picture. So this is the basis of looking at this parameter, and unfortunately to do that you need to reboot PGStat instance, because you cannot just change this memory on the go. Periodic snapshot is performed from cron, but there we address PSQL, take select, and snapshot is done. And then we are looking at, we make sure that there are no mistakes there. Making the reports, drawing the reports. There is a designated table where all the snapshots are placed. You can actually launch a query to it. You can, for example, launch a snapshot show 1, and it will give you all the snapshots of the last day. Then you need to select all the snapshots that you will use to build the report. Running the function of draw report, you set the period of time. If we are taking snapshots every 2 hours, well, we need to be 2 times quicker than Oracle, it means. But if we see that we need to be 2 times quicker, then we set the numbers accordingly, from 10 to 11, and the last 2 snapshots will make it to the report and will be analyzed. This function produces text. It gives you HTML text, same as Oracle. And you can send it to a simple HTML, to the ordinary HTML file, and look at it at the browser. What are you going to see there? There will be several sections there. In fact, there will be numerous. Cluster statistics will give you general statistics on the whole cluster. There will be 2 tables on database. First is database stats from PGStat database, and the statement set by database is the aggregate from PGStat statements on the observed snapshots. Then it is followed by SQL query stats. This is the most interesting part of the report. Everything will be like in AVL. Queries will be sorted and ordered by various properties, for example, by elapsed time. And by the way, that will be cumulative elapsed time. All the queries that were performed between two snapshots, we will get aggregated data on those queries, and the queries that spent most of the time, they will be ordered in a list and presented in this table. Then execution of queries, wait time, in and out, wait time. Then by gets and by temporary files, by temp files usage. And the same as in eval, we'll have a big list with the body of queries. Because in sorted tables, we'll have only statistical data. And in order to see the body of the query, we need to hit the identifier of the query, and it will send you to the bottom of SQL text list, and you will see what the query was about. Schema object stats. Those are pieces of statistics on schema objects. Most scanned tables, sequential scans. That is what it is. DML tables refer to DML operations, tables that had the majority of DML tables. Tables that got the majority of DMLs. Top growth tables, tables rated by, ordered by their growth rate. And for every table, there will be given information about how much it grew in between snapshots. Abused indices. Unused indices, in fact, in the version that will be coming out soon, it will get a different name. Unused growing indices, it will be called. So these are indices that receive data, but they are not scanned. Here we need to be really careful, because these are indices that were not scanned in between these two snapshots during the observed time. It doesn't mean that we do not need these indices, so please be careful about that. But, well, this is, in fact, a point where you should think about them. These are potential candidates if you take the representative period of time where all the indices should have been used. Then they are potential candidates. And by the way, these indices do not contain those, that do not include those that are needed to support constraints. IO schema object stats. These are tables that are ordered by the decrease of IO. Function stats. Here we talk about functions of PGCL. We have this mechanism in Postgres. We use it. There are very good meters there, and they show you which function took how much time. And you can have a good look at that. Vacuum-related statistics. Well, this is a vague section, in fact, because it is not incremental, neither cumulative. It only shows statistics for the last snapshot. Tables that you had at the moment of the last snapshot they're ordered by that tuples ratio and modified tuples ratio. There you also get the time of the last auto vacuum. Well, you can judge how well that one works, and well, this is the section that I'm still thinking about. I'm going to improve it more. The view of report tables. This is how report tables are going to look like. Report tables for database stats. We will have the number of commits, rollbacks, data on shared buffers, how many records, entries were received by instances, sent by users, how many temps were created in bytes in time, and how many deadlocks we had. This is how it is going to look like. And the same one for SQL, top SQL by elapsed time. But for other SQLs, it will be the same actually. Identifier of the query, the database where it was performed, cumulative time in between snapshots, total percentage. Well, this is a tricky thing. Please just be careful when analyzing that one. But when everything is okay, it will show you the percentage of the overall load. For example, elapsed time 1,600 seconds will be the aggregated time, these statements. And then it is followed by runtime. Sigma in normal distribution is an assessment parameter that you can use to assess the distribution of the runtime of queries. If the distribution is okay, but of course it is not okay. Well, if it were okay, then within the range of within the tolerance of one standard error, you will get 68% of queries plus minus tolerance of plus minus 2 will be 98% of errors. So this is the assessment parameter that gives you an indication of the distribution of errors. But it is not as simple, because identifiers of queries in PGStat statements, they are actually given in the right way from the point of view of statistics, because there the identifier is the hash of the plan of query, and that actually influences a lot on the time of performance and other statistics. But at the same time, it is not convenient for further analysis. If you use these identifiers, one in the same query can make it to several resulting tables, and it will be difficult to understand why it appears several times. So the identifier of a query is a hash, which is compatible with PGCenter utility. Hash is calculated according to an algorithm so that one query makes it to the table, to the reporting table, only once. Number of executions, well, it's clear here. So let's go back to our case. What happened here? In fact, in order to narrow our search, let us look at the size of database and how it was changing over that time. So let's look at the monitoring of the size of the DB. And here we see a boring straight line. We see that the DB size was not changing, and then it means that there are two options. It's either not Postgres or those were temporary files. As apart from Postgres, there is nothing else on the server. There is only one option of what that could be. But still, we do not understand why these temporary files appeared suddenly. But we have PG profile. We take snapshots every half an hour. So we take the most important snapshots. We take the first at 11:30 and the last one at 12:30, when everything calmed down again. And here we see a lot of temporary files right in the first table of our report. We have 7 GBs of temporary files. It was happening in registered DB, and then we're interested. Well, we see that these are temps. We go to the part of the report where we have a list of queries that are ordered by temporary files using. And here we see our heroes. We see three leaders that actually are responsible for the temporary space they used. We click on the query ID and we get to the table, complete list of SQL statements. And here we see a simple query. It is in small font, in small print. This is a simple query. It addresses one view, but we have the text of the query, and in fact, it looks like our developers built a view that was going through DB-Link by asterisks and getting something from the view there. On top of that, we put the conditions for selection. If they would run this query for 30 times, we would see this picture, but 60 times would kill the database. There was a project where they had to build analytical cubes, the developers, I mean. They've written a lot of PL, PGSQL functions. They are addressed one to another, and they came up to me and asked which functions actually spend too much time for us to understand what has to be optimized. No problem. We go to user functions by total time, and we see the functions that took the majority of time. The time is cumulative. Here we have only one execution, but we need to look at the fields of the table because we have total time, self-time, and average times. Total time is the time that was spent for running the function from the start to the end, and self-time is the time spent inside the function. For you to understand it better, the function inside can actually address other functions, and self-time does not include that. It does not include the time that is needed to run internal functions. So we're not interested in functions that have small self-time, but those that have self-time and internal time similar, they may be optimized. Applicability. Well, of course, it is important for solving the issues with the system performance. For example, the administrator comes to work in the morning and learns that something happened during the night. We look at the reports and understand what was happening. Abnormal load at the server. This is a different situation. For example, an administrator of hardware happens to come to you and tells you that that during the night something weird was happening. When we are performing load testing, we make the snapshot before load testing, and after load testing it's good if no users are using the system at that time, and then we start the report and understand what was the load that happened during the night. Actively growing objects. Some tables are growing rapidly, and admins usually know which tables are growing rapidly, and maybe they do something, give them specific conditions. Looking for unused indices, I've already told you about those. Other questions that other applications that can be, well, they may be different. Particularities to the setup. There is a very simple option. Just use this top line. Careful option is to put deep link into one. place and PGStat statements at another profile. The last one is written at PLPGSQL, and you will not need anything apart from that. It will create a lot of tables, and for those tables not to be mixed with public space, so it is better to dedicate specific space for that one. Setting of PGStat statements. You need to set the settings so that the statistics you need to get it to Postgres view, and you could use these statistics in full functionality. Parameters that the module uses. There are only two parameters that it uses. Top n means the number of objects that need to make it to ordered lists, and snapshots. This is a limitation, a constraint. The higher, the bigger figure you put, the more often snapshots will be taken. PG profile retention. Here we put the number of days. When this period expires, the snapshots are deleted. Baseline, well, it is similar to Oracle. This is actually a named object that has a name, and the starting and the first and the last snapshots, they are excluded from the policy, and if you're interested in the representative statistics you have, you can create a baseline, you can indicate the limited period of storage, or in other case it will be stored for an unlimited period of time. Problems. Well, there are a lot of problems. For example, collection of stats at the end of executing the expression. In Postgres, the statistics is collected after the expression is executed. If a select is running for the whole night, it will only make it to statistics after it is executed. So in the last snapshot in the morning, when this expression is executed, you will see that the database performed a lot of things, and it will show you that during the whole night it was not doing anything, but in fact it was doing. This is a problem. This is incorrect displaying, and we do not know what we can do about it as yet. PGStat statements track. This is a parameter that impacts the report tables. Here we can put top or all, and it means that we collect stats on executing expressions, only those that were launched by user application, or for all the expressions that were run from that. If we select all, then the result will be ridiculous, because the statistics will be calculated several times in the top level and through all the through other lower layers in the hierarchy of queries. And the percentage of the total will be, well, not very informative. We do not know what we do to it. If we put top, well, the percentage will be good, but we will not know what happens in the internal queries. PG relation size. It actually deblocks exclusive lock in the table. We use PG relation size for user objects in the table. It is run through dblink when the snapshot is taken, but if dbl was run in this table, then PG relation size will be waiting for lifting this exclusive lock. It means that snapshot will not be taken. In the current version, it is so. If we set cron that is going to launch snapshots, it will not do us any good because the snapshots will become numerous and they will all be waiting for lifting this lock. The next version that will be released, well, I recently understood that in fact the developers can do that. I'm going to put constraint on lock timeout so that if within 5 minutes we do not succeed to execute this query, this query will be down with an error, but it will prevent from the snapshots multiplication. Storing in snapshots only top n entries. Well, that can be the reason for imprecision, and if we are but if we look at the statistics for several snapshots, there are the statistics between the first, for example, and the second snapshots are somewhat inconsistent. But this happens because the snapshot is limited in size. It should not be too bulky either. That is why they are not complete. There are other problems that are related to what is available in Postgres in general. To have representative data on our statements, in fact, we lack a lot statistics on the waiting time, so that we could understand what the expression spent its time for. It would be great to get the information about when it was actually doing something and when it was waiting for the CPU. If there were not a lot of readings and a lot of time is spent, then probably there were some deadlocks. This is an indirect criteria, so waiting statistics would be great, in fact. And other incremental cumulative meters that will be appearing in Postgres, they will significantly expand the function of this extension. Well, that is it in general on my part. Any questions? There are quite a few.
Скажите, пожалуйста, снимаем снапшот.
Okay, we're taking a snapshot.
HTML, может быть,
then
планируется как-то
we put it to HTML maybe. I'm going to diversify this information and build statistics in Graphon so that in the morning when we come to work, we could, for example, set up new alerting, or we wouldn't have to go to the server directly. And say if we have it 100 or 500 or 1000, and if we had aggregated statistics, even if it is raw or maybe after aggregation, if we had a mechanism to get to it, that would be great. Okay, I got you. It depends, in fact, on what you want to get. Graphon, in fact, this is a tool for dynamic monitoring, and it needs to get statistics about what is happening right here, right now. And you are going to set your alerting in regards to that. If you want to base your alerting on aggregated data, well, we don't have ready functions. The ready functions that are built in reports that are used to build tables that will make it to the report. But in fact, you can run the same queries and write a wrapper for them that may be actually run from anywhere. It will give you, it will produce a table with all the data that you need. I don't think it's a problem. We can do it. The question is of the microphone.
Yeah, here, see, you can execute your query to the tables of this extension, but still, as I already said, we're writing function inside of the extension that will be applicable for several snapshots. It will provide aggregation and make it represented as a table. Then you get this data and you can load this data everywhere. The question is, how will you do this? Will you do it in one night? Overnight? Yes, we can do also like this. But the question is, where do you get coordinates from? Coordinates of the snapshots. You need a kind of artificial intelligence for this. Of course, you can take it out of tables, but still, it can happen that you won't take this snapshot for the previous time. Thank you very much for your lecture. The interface that is in the version 9.6, have you seen it? So speaking about statistics of waiting, I am speaking not about an interface that is in PGStat activity. We just can take a look at what is waiting for a certain backend. But it's, as for now, what does it wait for right now? The function of snapshot is executed once in 30 minutes. Even if we would make it once in 1 second, we would not wait for backend waiting for the certain events. We cannot wait how much time did they spend to wait for this answer, for these responses. That means that the wait is momental. The main problem, the main issue of Badger is the production. But this is the overall state. Thank you very much. It was very interesting to listen to you. I have the following question. This extension is uses debugging to take the information from the bases of neighbors. Why do we need to write down the statistics into the same host? It's easy. I can explain this. The extension is made in the same way as the Workload way. It's written down for you for not to have Postgres. So you don't need anything. You don't need any other extensions. You don't need any other additional servers where you will collect statistics from. You don't need any structure. You just install it on the server, start cron, it collects everything, and then you can see everything. Of course, there are combinations with stat statements, with snapshot, but snapshot is taken for 5 seconds, I suppose. Even there are several databases. And it's not loading server for so much, but you don't need so much for it. That means you don't need to think about the possibility to compile all the statistics from all the servers, but this is not the main functional. And the main idea here is to build it on one server. And how many tables for this monitoring do you have on host maximum? So the project, we don't have the best projects here, but I think 5,000 tables. This is the amount that we have. Thank you very much for your information. We are not using it in interface in vanilla for this monitoring. Why don't we check up the PG logs? Why don't we make snapshots there for blocked objects. But why do we need what do we need it for once in 30 minutes? No, it won't fall out. Look, you made a snapshot. Then you have a block. It stays there for 25 minutes. Then it's the end of the block. Now you make the next snapshot, and everything is okay. Yeah, yes, I do agree. Do you have a overall statistics for buffers, cache hit casements? How many of them? Let me find some additional information. No, I don't need it. Thank you. But do you have it? Yes, I do. I will show it to you right now. Of course, we have the statistics, and I think it will be useful. Just for example, here, the same incident that I showed today. This is how it looks. Here in database stats, you see the block hit. These are the shared buffers. What about standby? Do you have standby statistics? We don't quite understand right now what shall be collected here for this topic. Positions in log? I don't think we need them. This is just the running state of standby. The thing is, we need just to see whether standby is working or not. Yes, but still growing or not growing. But this is not just monitoring. We don't need such historical data here. I think, speaking about block hit, it should be in SQL. No, it's not here. Yes, still, but if a block stays for 30 minutes or more, but still, it's made by monitoring. You just take your own means of monitoring, you look for long transactions, but it happens. Yes, but still, it's active monitoring, and you need to install your alerts for it. And this is more for investigation, I suppose. Like the same in Oracle. Yes, I agree. In this instrument, I don't need it. If you are working with an instrument of monitoring, then it's useful. Then you can take a look how long did you wait for it and so on. Yeah, thank you. I would add something out of my experience. We also use analog of your program, or the Oracle. I think there is SH in Oracle. Yes, there is. Active session history. So in my experience, for now, the most useful metrics that are collected are the blocks. And they are made not once in an hour. Now they're making these statistics every 30 milliseconds. It's very strange that you don't collect snapshots of PGStat. Yes and no. Here snapshots are collected for huge guns, like for once in an hour or once in half an hour. We don't understand why to do this. No, it's convenient because you can evaluate the wall statistics. Yes, still I think the wall statistics will be at us. Please write to us. Please join the community on GitHub, and we will speak about the statistics of wall. I think it would be useful. So, if you have a time period, like for an hour, and you encountered some problems with productivity, you could you could use PGStat or PGWriter to understand what cats were in sync. So, in my experience, it's the most useful table out of all PGStat asterisks. Yes, thank you. I will take a look at the possibilities. It's rather addition, but not question. Perhaps you cannot know this. In professional, there is a PGStat late I'm sorry, I cannot hear the question. It's not in the microphone. Perhaps you should read and introduce it. No, this is a great story. It's a normal way, and it's for production use. Please choose the function that calculates the file size on disk. PGCL? Is there such function? Yes, this function is developed at PGCL. The function that is not using a blocking mean to calculate the amount of the relation. So I have this at my home. I can send it to you to GitHub, or could you give me your email? Then you can get rid from the obstacles. You won't need to delete any blocks. Yes, I think it's possible to do this. You need to do this. But there will be many files, and you must run through many files. It will still, though, it will make it all. It will open buffer and calculate everything. Yes, I think it's possible. Yes, and one more question, please. But I think it's very rare for now to see a problem. But I think once in 10 minutes you should make it, but not once in an hour or once in half an hour. No, we're searching for serious problems. Look, Oracle makes it like this, once in an hour, and they are not idiots, I suppose. And you can adjust it for another time, of course, but please, it's cron. You can write everything even once in 10 minutes. It's no problem. The question is, we are searching for serious problems, serious issues that affect our productivity. And Aquila don't. If the load was okay and this was solved during 1 minute, it's not important for you. Perhaps it could be interesting for you, but this load you will not see it in any other criterias comparing with the overall load. But our practical experience shows that for Oracle, 1 hour is okay. For us, half an hour is pretty okay. Are there any filters that are working with pgstat statements and not passing through? Because I tried for 3 months ago the thing that was published on GitHub, and I made snapshots. I counted. Yes, I don't know what version did you install, but this was 3 months ago. I think 3 months ago it should be the 4th version where all bugs were fixed. The question is, we exclude only the things that are not in tops. So if you were working with an empty base, I think it would be better when you would send the information to me, the example to me. But I thought the top is that thing that was fulfilled, and the questions, the queries should be in the top. Yes, they should be, but top was empty. Please send us the case. It's very interesting for us to take a look at it. Thank you very much for this interesting instrument. The question is about temporary tables. Can we distinguish between the assortment on the disk, the sorting on the disk? Yes, you will see it in statements for time usage here. 1 moment. Yes, top SQL by temp usage. You go to this directory, and I think in the principle in your database, you won't work with many queries that are using temp. So the principle of tops is applicable here. Top 20 or top 10 you will see here, but not the others, only 10 or 20. So speaking about database, you will see how many databases, how many temp was created by databases. this terrible figure will not be in the new version. It will be normal. Will it be distinguished between temporary files that will be used by database? No, because pgstat statements is not telling us about this. It's just telling us of what it has done with temp, but about sortment we don't know this. Thank you. My name is Roman. Thank you very much. I wanted to ask you whether you came up with the idea to use the khash, pgstat khash, out of 9.4 to get more detailed statistics on the basis of statements. Yes, perhaps I will evaluate this. Is this a standard part of Postgres installation? Yes, I suppose so. Well, I should take a look at this. Perhaps we could we could use it, but I did not evaluate it before. Yes, we can distinguish between time and user time and disk. Yeah, it all depends whether it is a standard part of installation or not. Because the thing is, we don't need anything. Because we need to feed it to Postgres then. But if we need to install something additionally, it won't be the best way for us. Thank you very much for the information. Did you try to go off from the idea to collect the statistics for different types, statistics with different intervals? Perhaps it would let you to make a copy of what pgstat.let makes and collect once in a second or once in 100 milliseconds the statistics for waiting, and to select once in an hour it from pgstat statements. Yes, we can do this. We can write down new functions that will make additional snapshots and call them from cron, but it's impossible to call cron once in 100 milliseconds. You will need to write some additional tool. The thing is whether it is logical or not. We need additional statistics, reliable statistics, and it's very strange to look for this option. Perhaps we can find an extension if it is a standard extension, but we don't want to add additional tools. Thank you very much. It's out of the microphone. I would like to ask you about PG statements and temporary tables. In the view, in the extension, there are certain fields, like temp file. So the tables. We could glue table and glue temp. Plus there are counters, log, block, hit. And this is also a part of statistic for temporary operations. And if you don't have work memory, you could create temporary file and create statistics for the temporary files. I think we should bear this in mind. And the statistics and this information could be then located in temporary tables. Yeah, thank you. Any questions so far? Then thank you very much for your lecture.